Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel. If this is your first video, welcome. So today we're going to be continuing the series on how to solve trigonometric functions using the product rule. And in this particular video, we have our function to be tan x multiplied by cosecant x. And of course, you've seen the thumbnail, the title, as well as listen to the first few things I said at the beginning of this video. You know we're going to apply the product rule. But the reason why we're applying the product rule is because when you have two or more subfunctions multiplied by each other and you're asked to differentiate that function, what you're going to need to apply is the subfunction. What you're going to need to apply is the product rule, right? In this case, the subfunctions that we have are two. We have tan x and cosecant x. And there are two subfunctions multiplied by each other. Hence, you need the product rule. So when we compare positions, we can see that the first position in the general equation is f of x. That's the first subfunction, and that is equivalent to tan x. So hence, that's why we have this here. The second subfunction, g of x, is the same thing as cosecant x. Hence, why we have this here. When we apply the product rule to this general information, we have the derivative of the first subfunction f of x multiplied by the second subfunction g of x plus the derivative of the second subfunction g of x multiplied by the first subfunction f of x. So since we know that, we can start solving. So what is the derivative of basically what we're doing here is we have the derivative of tan x multiplied by cosecant x, right? So the derivative of f of x in this case is derivative of tan x multiplied by g of x, which is cosecant x, plus the derivative of g of x, in this case cosecant x, multiplied by f of x, in this case tan x, right? So the next thing we do is we start. What is the derivative of tan x? Now, before you go further, I have a page dedicated to this trig information, which is called Trig Notes. So if you're new to my channel, you probably don't already know this. And on the left side of the page, we have a place dedicated to trig expression. So basically how one trig function relates to another trig function. Here we have sine x equals to 1 over cosecant x. At the bottom of that, we have cosecant x, the same thing as 1 over sine x. So basically how trig expressions relate to one another. That's really it. How do they relate to one another? That's what the left side of the screen is telling us. Now on the right side of the screen, the top right, we have trig identities. What is trig identities? Here is the same as in sine square x plus cosine square x equals 1, or cotangent square x plus 1 equals cosecant square x. Obviously, from the first and the second, you can notice that something is going on. For trig identities, this is just basically when trig functions have squares, and that is it. When trig functions have squares and how they relate to one another. And then the last one here is trig derivative. So everything that is written in the red marker on this page as related to trig functions are trig derivatives. And that is what we need right now. It was asked, what is the derivative of tan x? What the derivative of tan x is our gorgeous secant squared x. So we put that here. So we have secant squared x as the derivative of tan x multiplied by cosecant x, as that just drops down, plus what is the derivative of cosecant x? The derivative of cosecant x is negative cosecant x multiplied by cotangent x minus negative cosecant x cotangent x, right? And then multiplied by tan x. So what you end up with is secant squared x cosecant x minus cosecant x cotangent x tan x. So this is basically the answer. So if you just want to apply the product rule, you've done a great job so far, and this is it. But then because you're doing trig, it's important for you to simplify your question. In fact, in mathematics, anytime you're given a question that can be simplified, basically even simple things like fractions, when the numerator and the denominator are even numbers, you can cancel stuff out. You can factor out a 2 or whatever. You can cancel that out. In this particular case, we have trig. And the best way to handle trig is for you to substitute and look at the trig information that you have, in this case, our answer, and just basically play with the other trig expression, the trig identities, and just mix them all up and just simplify. That's what we want. We want a more simplified answer. And that's what we're going to do on the next page. So we have secant squared x. I'm rewriting what we had so we can simplify it. Secant squared x multiplied by cosecant x minus cosecant x cotangent x tan x. So that's what we have. In my videos, I like to break down complex trig information into sine and cosine in order for me to see it more clearly. So we have secant squared x. What is secant squared x? Secant squared x is the same thing as what? Well, from our trig expression, we don't have anything that relates to secant squared x, but what we have is something that relates to secant x. Secant x is the same thing as 1 over cosine of x. So we can put 1 over cosine x. Since it's squared, we can say 1 over cosine squared of x. Because if we have 2 secant squared x multiplied by each other, it's like having 2 1 over cosine x multiplied by each other. So hence our answer will be 1 over cosine squared x. And then we have cosecant x. What is cosecant x? Well, cosecant x is the same thing as what? Cosecant x is the same thing as 1 over sine x. So we have multiplied by 1 over sine x, okay, minus, what is cosecant x? Again, we just did it here, so that would be 1 over sine x. Now, what is cotangent x in terms of sine or cosine or both? Well, cotangent x is the same thing as 1 over tan. But 1 over tan is the same thing as cosine over sine. So here we have multiplied by cosine of x, multiplied by sine x. Interesting. Then we have tan x. What is tan x when we look at the trig notes page? Tan x is the same thing as 1 over cotangent x, which is also the same thing as sine x over cosine x. So we have sine x over cosine of x. So now that we have that information, what should we do? Well, what we can do is, since the goal was to simplify anyway, we can cancel stuff out. We have sine x here, sine x there, cosine x here, cosine x here. So what we have here is going to be 1 over cosine squared x, right, multiplied by 1 over sine x minus 1 over sine x. So this is our answer. Like every other mathematician would do, we're going to bring out 1 over sine x. And you put that out and you have 1 over cosine squared x, right, minus 1. Okay, so that's it, right? But our work is not done, because looking at it and just being able to play with trig, there's something else that we can do. We have the denominator here to be cosine squared x. What can we turn cosine squared x back to? Well, cosine squared x can be returned to 1 over, cosine squared x is what we have at the bottom, which is the same thing as 1 over secant squared x. Well, we also have 1 over cosine squared, 1 over cosine x is the same as secant x. Since we know that, we can say 1 over cosine squared x, right, as, so we have 1 over sine that we brought out. We can have this information here as just secant squared x minus 1. So we have that, right? Now, work is not done again, because this is looking like something familiar. So we go to the trig notes and then compare what we have so far. From the trig notes, we know that we're dealing with secant x, but our question is secant squared x minus 1. when we compare secant squared x minus 1, that means we have to take negative 1 across the equals to sign. So we're going to have secant squared x, right, minus 1 minus 1, and that is the same thing as tan squared x. If you don't see what I'm doing, please look up top to the right part of the page of the first half. So what I just did in black, so tan squared x is the same thing as secant squared x. So let me rewrite that here in green. Tan squared x is the same thing as secant squared x minus 1. So we end up with this equal to 1 over sine x, right, multiplied by tan squared of x. So that's what we have here. So the derivative of tan x cosecant x here, and this is our answer. But then again, it's trig, we can do something else. So we have our answer to be 1 over sine x, right, is the same thing as tan squared x. Now this answer is okay, but in fact, let me just quickly explain this to you. This answer that we got here is alright, is correct when you apply the product rule. This answer that we just got here is also correct. Talking about this answer I'm circling in green here, that is correct. This answer is also correct. We're just trying to make our work neater by making sure that everything we end up with answers that are, if possible, in terms of sine and cosine. If not possible, then at least we have answers that do not have squares. So you have 1 over sine squared x. Well, what is 1 over sine x again? You know 1 over sine x is 1 over sine x, right? But what is tan squared x? We know tan x is the same thing as sine x over cosine x, right? But then, let me prove that to you. From the trig notes, you know that tan x is what? Sine x over cosine x, right? But now we have tan squared x. Tan squared x is the same thing as tan x multiplied by tan x. So therefore, sine x over cosine x multiplied by sine x over cosine squared over cosine x. So tan squared x is the same thing as sine squared x over cosine squared x. Now let's just do what we can do. We simplify further. We cancel this out. So we end up with sine x over cosine squared x. And we can write that down as sine x over cosine x, okay, multiplied by 1 over cosine x. And what we end up having is tan x over secant x, right? So remember, if you remember, 1 over cosine x is the same thing as secant x, right? So 1 over cosine x is the same thing as secant x here. This is it here. Now, we have all of this information. Therefore, the derivative of tan x cosecant x, right, is the same thing as tan x secant x. Now, I'm going to teach you the shortcut method as it applies to this question. So the shortcut method, so we don't have to do this entire work. Like if we can avoid doing this much work, especially if you have a situation where you're doing an exam or an assignment where you have multiple choice questions and you don't have enough time. One thing you can do is remember that function f of x is tan x cosecant x. So tan x is the same thing as sine x over cosine x. And cosecant x is the same thing as 1 over sine x. So all of that. So f of x is the same thing as sine x over cosine x multiplied by 1 over sine x. So the next thing you have is f of x equals 1 over cosine of x, and that is f of x equals secant x. Now, we can now differentiate the function that we had in the first place, but we broke it down using trig expressions, right? So the shortcut method involves us breaking down trig functions by using trig expressions and breaking it down into bits, and then we can now derive the broken down information. So the derivative of f of x or derivative of secant x right here, not too much to worry. Like I said, if you're in an exam and you're trying to hasten up, if it's a multiple choice question, what's the derivative of secant x here? The derivative of secant x is the same thing as secant x tan x. So our answer here is secant x tan x. So therefore, f of x that is equal to tan x multiplied by cosecant x is the same thing as f of x equals secant x, and the derivative of secant x is x secant x tan x. Now we compare it to our actual answer. What did we get? When we did all of this information from here, we broke down secant squared x, cosecant x minus cosecant x, cotangent x, tan x. We broke all of that information to tan x multiplied by secant x, and we can confirm that answer is correct using the shortcut method, because we also got secant x tan x. So that's the end of the video. Hopefully this video was helpful to you guys. If you like this video, please subscribe. And if you have any suggestions, please put it in the comment section. If you have any questions, look at the description box to make sure that the question has not been answered in the description box. If it's not been answered, make sure to write down the question in the comment section. Have a good rest of your day. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.